Let's take an example in which you are given that this rotation matrix here relates frame A, frame 1 to frame 0. Okay, so it takes a vector from frame 1 representation and projects it to frame 0 representation. Okay, this is the matrix as given here. And we are given a vector u in frame 1, okay, that is equal to this, okay, there's a transpose here that I forgot to put. This is a vector, column vector, okay. So u1 is 1 over root 2 and 1 over root 2. We would like to find u0. We'd like to find u as represented in frame 0. This is easy because basically what we want is u0, okay, as in the slides. You see here in the slides, we just utilize the same. So we have exactly the same problem here, okay? So P0 is equal to R1 to 0 times P1. So here we have U0 is equal to R1 to 0 into U1, okay? So, and this equals to, I can take the root 2 outside here, okay, of the matrix, so that it becomes easier for me to write. So this is 1, and then minus 1. So the root 2, 1 over root 2 is taken outside of the matrix as a common factor because it appears in all the elements, okay? So in the first column, I have 1 and minus 1, that is multiplied by 1 over root 2 outside the matrix. And then the second column is going to be 1 and 1. And that is also multiplied by the 1 over root 2. And then I multiply this by u1, which is also I'm going to take root 2 outside, 1 over root 2 outside. And I'm left with 1 and 1, right? Okay. So that equals, okay, you can see that I have 1 over root 2 here and 1 over root 2 here. So that becomes a 1/2 here, okay? And then I just multiply these matrices together. So this or matrix by a vector, basically. So the way to do that is this row times this column. This gives you the first row, and this row, and then this row times this column, this gives you this row. How do I know the dimensionality of the result matrix? Basically, this is a 2 by 2. This is a 2 by 2 matrix, and this is a 2 by 1. So the dimensionality is going to be 2 by 1, okay? 2 by 1. So I should expect a 2 by 1 matrix. So it's 1 times 1 plus 1 times 1. Where did I get this from? It's 1 times 1 plus 1 times 1, okay? And then in the second column, I have also a minus 1 times 1 plus a 1 times 1. And that is equal to 1/2 into 2 and 0, which equals 1 and 0. Does this make sense? Let's see. So u in 1 is 1 over root 2 and 1 over root 2, which is basically pointing towards this direction here. Okay. All right. And this vector here, which is u0, is also 1, 0. Okay, it's 1, 0, which is basically the same vector as the one in u1. Okay, same vector as in 1, but different representation. That's all. So you're picking which frame to represent u with, whether it's u1 or u0. Okay, let me stop here and continue this example in the next video.